Hello everyone, I am Jessica Guzman and I'm about to report about a table effect short tube evaporator for my heat transfer equipment design. Evaporation is a heat transfer operation wherein a more volatile solvent is evaporated in order to concentrate the solution. The fluid that I chose for my design is glycerol. Some of its industrial applications include skincare for cosmetics, cleaning purposes, biodiesel manufacturing, pharmaceutical, paper and pulp, and textile industries. Short tube evaporators, they are also known as calandria or Robert evaporator. This kind of evaporators are used for solutions that require low residence time. Multiple effect evaporator unit consists of a series of single effects. It has a high economy because the usage of live steam is not done for each effect. Forward feeding is the type or method of feeding that is suitable for warm feed and solutions with low viscosity. It will not require any pump to transfer from effect to effect, but will require one to feed liquid into the first effect and remove thick liquor from the last. Problem statement. Glycerol solution is to be concentrated from 7 to 80% weight percent. The feed is available at 50,993 kilograms per hour at 27 degrees. Steam is available at 103.66 kilopascal, the first effect, and is maintained at 74.2 millimeters of mercury in the last effect. This is the material balance for the evaporators. The typical heat transfer coefficient for short tube vertical natural circulation is 1100 to 2800 watts per meter squared Kelvin. We assume a value of overall heat transfer coefficients for each effect based on a common OHTC of vertical evaporators. Various calculations are performed. The evaporation rate, the concentration in order to get the boiling point rise for each concentrations. Assuming that the heat transfer for steam to the solution is the same for all effects, the Q's were equated. Delta T, actual boiling point, were computed, and after collecting the necessary data, the overall mass balance is used to form equations which will lead to the computation of each rate. It includes the heat transfer rate and the area, which will be 232 meters squared. For the design, I used 5 4-inch nominal diameter 80 scheduled tubes of 10 feet length whose dimensions is flashed. Surface area, number of tubes required, and area occupied by tubes is also computed. Downcomer is unnecessary for this evaporator since it leads the gas downward. So the area and diameter of the downcomer is computed as long as the total area of tube sheet in evaporator, thus computing the sheet diameter of the tube. Low carbon steel and brass are the materials of construction for the evaporator and tubes respectively. Calandria sheet thickness was computed, tube sheet thickness, evaporator drum diameter, and drum thickness. Auxiliaries, pumps, condensers, and impellers. Pumps feeds the liquid into the effects. Condensers converts or condenses the vapors from the last effect while impellers are used to aid circulation to minimize fouling. This is my prototype, and thank you so much for listening.